Hi guys, I am Darshana from ITA. Today my topic is Introduction of Digital Counter. Let me see the definition of digital counter. A digital counter is a sequential of logic circuit that progress through the predefined sequence of states upon the application of input pulses. A counter is nothing but it counts the number of pulses that arrival in the clock input. Purpose. Counter are integral to timing, sequential, and control the operation in digital system. They keep the track of the accuracy or generate the specific timing signal. Next, the fundamental building blocks of flip-flops. Flip-flop is the heart of digital counter. These are the basic elements capable of storing a single binary bits 0 or 1. By connecting the multiple flip-flops in specific configuration, we can create circuit that change their state in predictable sequence, effectively counting. In this diagram, the D represents the D flip-flop and I clock is a central element. The Q represents the primary output of the input pulses. The counters are classified into two types. First one is asynchronous counter, second one is synchronous counter. Let we see first asynchronous counter. The output of the one flip-flop serves as the clock input for the next. This creates then a ripple effect. Ripple effect, it's nothing but it's a single action or event that continuously spreading consequently. There are the straightforward to design and construct. It's easy to implementation. Speed limitation. The ripple effect introduce propagation delay, meaning output don't change simultaneously. This limits their speed can cause issues in high frequency applications. Second one is synchronous counter. Unlikely asynchronous counter, all flip-flop in synchronous counter are clocked simultaneously by the common clock signal. This ensures that all output bytes change state at the same time. It's a faster operation, more complex design due to the additional logic gates for control, eliminate the ripple effect, providing stable outputs. In this diagram, it's represent the 4-bit upper counter. Next, understanding modulus, counting capacity. Modulus is nothing but the total number of unique states a counter progress through before spreading its sequence. These are two types, standard modulus and attribute modulus. Standard modulus. An n-bit binary counter has 2 power n possible states. There are 4 bit, therefore a 4-bit counter has the modulus of 2 power 4. Its total is 16, counting from 0 to 15. The total values are 16. Attribute modulus. The counter can be designed to have a modulus other than 2 power n by additional logic to resets then counter at the specific counter. For example, modulus 10 counter, it's count from 0 to 9. Next, key performance merits. Maximum operating frequency. The highest clock frequency at which counter can reliably operate. Critical for high-speed digital systems. Propagations delay. This time taken for signal change at the input to propagate to the output of the gate or flip-flops, accumulating in asynchronous counter. Next is the common application of counters. Time and alarm, frequency counter, digital watch, digital clock. These are the common application of counters. Next, advanced counter concept. Up and down counters. These counters are increment or decrement based on the control input, useful in bidirectional counter systems. Presettable counter. These counters be loaded with an attribute initial values. This is crucial for application requiring counting from the specific starting point. The last slide is counter in sequence performance counter intelligence. Fundamental counters are built from the flip-flops for sequential counting. Types: asynchronous are simple but slow, synchronous are complex but faster and precious. Modulus defining counting capacity can be in standard 2 power n. Performance: frequency and propagations delay a critical for application found in this application for timing to control with advanced features like up and down presettings. Thank you for watching this video.